Hi students, welcome to physics classes. Today we'll discuss one of the most important question, total internal reflection. Total internal reflection. Here we did one activity. We discussed one activity. What is the relation between angle of incidence and angle of refraction when light ray traveling from rarer medium to denser medium? We discussed one activity. What is the relation between angle of incidence and angle of refraction when light ray traveling from rarer medium to denser medium? On the day we have taken pro circle, which consists of 0 to 90, 0 to 90, 0 to 90. And on the pro circle we placed semicircular glass disc. There we placed up semicircular glass disc and we sent light ray from rarer medium to denser medium. How we traveled we discussed. If anybody didn't see the video, I'll share that link in the description. You can see. Now here the change is we should take light ray passing from denser medium to rarer medium. Here we should take light ray is traveling from denser medium to rarer medium. Remaining everything is same. We have taken the pro circle. On the pro circle we placed semicircular glass disc and diameter of the glass disc coinciding with M and M and center with O. Like this we kept. Now we should send a light ray from this side. We should send light ray from this side. Then here it will enter from denser medium to rarer medium. This is the interface. Denser to rarer. Already we know when light ray traveling from denser medium to rarer medium, it bends away from the normal. It bends away from the normal. First we will send one incident ray. We will see that. Now this is the incident ray by making some angle with normal, and this is the refracted ray. This is the refracted ray. Now for particular angle of incidence we got refraction, angle of refraction. When compared to angle of incidence, refraction is more. It bends away from the normal. Now if still I increase angle of incidence, so it still comes towards the surface, interface. This is the interface. Separation of two mediums. This is the interface. Whenever still I increase the angle of incidence, light ray still comes towards interface. At one particular angle of incidence, it grazes at the interface. At one particular angle of incidence, refracted ray grazes at the interface. That we will draw now. Now here this is the incident ray. This is the another incident ray. When compared to this, more angle of incidence is increased. So at particular angle of incidence, the light ray grazes at the interface. It travels here. This angle of incidence is known as critical angle. See, this angle of incidence is known as critical angle. Critical angle. Now we will see the definition of critical angle. When light ray traveling from, very important definition, when light ray traveling from denser medium to rarer medium, when light ray traveling from denser medium to rarer medium, at one particular angle of incidence, refracted ray grazes at the interface. gauges at interface at particular angle of incidence, at particular angle of incidence, at particular angle of incidence, refracted ray gauges at interface. That angle of incidence is known as critical angle. That angle of incidence is known as critical angle. When light ray traveling from denser to rarer at particular angle of incidence, refracted ray gauges at the interface. That particular angle of incidence is known as critical angle. We can say in another form also. When light ray traveling from denser medium to rarer medium, at a particular angle of incidence, angle of refraction becomes 90 degrees. Now here this is the refracted ray. Angle between normal and refracted ray is 90 degrees. At particular angle of incidence, refracted ray, angle of refraction becomes 90 degrees. That angle of incidence is known as critical angle. That angle of incidence is known as critical angle. Now, still if we increase, when we send with this angle of incidence, it is refracted. Still more is there, it is gauges. Still more if you, still it should come away from the normal, no? Now, when angle of incidence is more than critical angle, the light ray totally reflected into denser medium. It not enter into rarer medium. It is totally reflected into denser medium. It not entered, it is not refracted. It is reflected, not refracted, reflected. This is known as total internal reflection. Internal reflection. When light ray traveling, definition for total internal reflection. When light ray traveling from denser medium to rarer medium, when angle of incidence is greater than critical angle, angle of incidence is greater than critical angle, light ray reflected into denser medium. It not entered into rarer medium, it reflected into denser medium. This reflection is known as total internal reflection. This reflection is known as total internal reflection. Here why we are saying total internal reflection means we should know one phenomenon. Now when light ray traveling from denser medium to rarer medium, generally are we able to see that glass? We are able to see that glass. We know reflection of light. When an object we are able to see means, if we are seeing any object means light should fall on it and it should reflect. If you are seeing any object means, for example here you are able to see this pen, means light is falling on it and reflecting. That reflected ray reaches to our eyes, so we are able to see this pen. Here whenever light ray traveling from denser medium to rarer medium, some portion of the light is reflecting. Even it is a glass, a small amount of light is reflecting. That's why we are able to see that glass. Otherwise we can't see, no. If there is no reflection we can't see, no. So light is, some portion is reflecting. When light ray traveling from denser to rarer, some portion of the light is reflecting, but we are neglecting it. Most of the light is entering into other side, so we are saying it is a transparent. Now here in this case, not some portion, total reflection. Total reflection. That's why it is total internal reflection. Normally when we send light ray from denser to rarer, some portion will be reflected. But here total reflection. That's why we are saying it is total internal reflection. This is very, very, very important activity. Once again we will take brief on it. We should take like a lab activity. activity we have taken relation between angle of incidence and angle of refraction, rarer to denser. Reverse, we are sending light ray from denser to rarer. Now first send one incident ray from a denser medium to rarer. So by making some angle, let us take it is 10 degrees. It is entered into other medium. Repeat it and repeat the same procedure for 20, 30, 40. At particular one angle of incidence, we won't see the refracted ray. We won't see the reflection. That angle of incidence is known as critical angle. If you still increase angle of incidence at one particular angle of incidence more than critical angle, light ray reflected into denser medium. This is known as total internal reflection. Definition: critical angle. When light ray traveling from denser medium to rarer medium at particular angle of incidence, refracted ray grazes at the interface, or angle of refraction becomes 90 degrees. That angle of incidence is known as critical angle. If light ray traveling from denser to rarer, angle of incidence is more than critical angle, light ray reflected into denser medium, that is known as total internal reflection. That is known as total internal reflection. Okay, that is the activity. Thank you for watching. Please subscribe.